And I'm recording, so Edwin, you can unmute and go ahead and get started.
Okay. Okay, good afternoon, everybody. My name is Edwin Flores, and I have about 10 months of being part of the Takeoff team. It's a pleasure for me to have the opportunity to share a little bit of the experience that I live in 2 years working in the shop with the topic that I will present to you, which is a shop production overview. As you know, Walt has extensive experience in the product and services it offers. Quality achieved through the years has been demonstrated in each one of them, not without first having gone through learning and improvement processes. All these processes start at the time our services are required by the customer. Engineering department in a specific moment take the control to release shop drawings, fabrication drawings, pallet schedule, etc. directly to the shop of our company. But what happened after that? What is the next step? Who are the people involved in the physical creation of each product that we know in our drawings or in our software? Some of these questions are the ones I will try to answer in this class, seeking to show that our job goes beyond our desk and it represents a legacy of life for all who participate in whole Walters and Walt process. Sorry. Okay. Let's go. I think to begin, it's a good idea to explore about the objective of my presentation. Some of them are know how to release information from the engineering department flows in the shop production, show the internal organization and the different production divisions in the shop, learn about the material and human resources, use manufacture the unit, use to the manufactured unit. Sorry. Observe each division of the production line and show some of the issues that happen and their relation with the engineering processes. Introduce some of the people behind the manufacturing process of our product and how important are each one of them in the Walters and Walt processes. In this slide, we can see that Walters and Walt currently has 7 shops in 4 different states. One in Seattle, Washington, one in Las Vegas, Nevada, one in Gilbert, Arizona, and in California, there are 4 shops, 2 in Laverne and 2 in Fremont, where we can find shop A and shop B. And it's precisely in shop B from Fremont that I'm going to base my presentation due to the experience that I had there while I was a production worker. I decided to take shop B like example, understanding that all the shops would follow the same process in production line, perhaps changing something but following a general standard. The shop is organized based on experience that through feedback has managed improving the production time and quality of our products. In the shop, all resources are in constant movement. The shop works around 18 hours a day, divided into shifts. In general terms, all shops are managed by a shop manager, but each shop has a shop foreman who keeps constant study, revision, and control about the whole process in 3 moments: before, during, and after the shop production. The shop foreman verified strict compliance with the production process, respecting design, criteria, and special conditions previously reviewed and approved in releases from engineering. He is also the connection between engineering department, shop, and field. Parallel to the shop manager and being support to him, we find the QC supervisors and leaders of division in the shop, all of them following and taking care every part of the production. The shop production follows a direct production line. However, there are lateral divisions that perform support function to the main production line. To try to explain it better, after engineering department made releases, the first division we find is receiving, which distribute product and material to fabrication, following the direct production line. But receiving also distribute to critical part, alcoholic, and glass. All these three are lateral division, which then distribute material to division on the direct production line, where we can find, in addition to fabrication, assembly and packaging. Between assembly and packaging, there is an important support division, which is unit test, and it's a filter to know the quality of the assembled unit, doing an internal feedback before units are shipped to the field. In all the shop process exists an important feedback loop that permits to know issues to fix, and most important, that any mistake or problem permit us to learn and improve every day. Well, this was an overview of how the shop is organized, and now we will explore a little bit of what happened in each division and who are the actors that are part of the shop production. Well, like a part of the diagram, talking about shop organization, that I showed you, before the shop production start, from engineering department, all necessary documents previously reviewed and approved must have been released, because all of them will be the guide to follow in the production. As you know, some of them are pallet schedule, glass schedule, panel schedule, all the releases like fab ticket, unifab, metal, glass, etc. This is the information with which we are familiar, but before going to shop production, it needs to pass through many filters, and the last filter is programming, where the programmer gives a last review to the information released to avoid any issue. And it's here in programming where the real shop production begins, because the programmer enters all the information to the shop machinery to fabricate the part of, for each unit. If we keep moving on the direct line of the diagram, we will find receiving. After the information from the engineering department has been released, the first stage of shop production is receiving. In receiving is entered the material that will later become the unit that have been designed and checked in the engineering department, like glass, aluminum, fastener, composite sheet, panel, and other. At this point, the material has not been fabricated, so it's distributed to the different divisions of the shop in stock lengths, sheet, etc. The glass goes to glass division, which will classify and distribute distributed to assembly. For aluminum, the group material flows was created, which has the specific function of making the aluminum profile package of material that will enter to its respective fabrication, which later will be used in assembly. The packages can be formed based on daily production scheduling or cut list. Composite sheets go to alcoholic fabrication, where they will be slotted and folded to become panel. Fastener, panel, attachment, and other go to critical part, who will distribute them to fabrication and assembly or directly to the field. Alcoholic. For alcoholic fabrication, we are going to move to the side of the direct production line of the diagram. Alcoholic is one of the lateral divisions of the shop production line, and basically it's a fabrication line apart because after finished composite panel, they ship them directly to the field. However, in some cases, the composite panel are fabricated to be part of unit in the shop production, being delivered to assembly. For the specific case of alcoholic, it's the panel team which create, check, and release drawing and cut list. But again, it's necessary to program the multicam machine. Like a mini production line, alcoholic fabrication receives composite sheets from receiving. Then they put this sheet on the multicam machine previously programmed, and following the cut list, every sheet is slotted to fold based on the design. After folding the slotted sheet, paying attention to the correct fold angle, all necessary attachments are added. When the composite panels are finished, they will be carefully placed on pallets to be transported to the field or to the production line. The production here is per day, and normally multicam machines slot 20 units per day, but people can fold around 30 sheets depending the quantity of fold in each panel. Critical parts. If we follow the shop organization diagram, we can find critical part, which is an important lateral division because it represents support for the direct production line. In critical part, gather, classify, and store all kinds of fastener, attachment, aluminum panel, and a special part to distribute them based in the job. Pallet schedule or glass by pallet, paying attention to the order or fabrication and assembly. Another function of critical part is receiving all return material, leftover part, and fastener of the project when these have already been completed. The glass division. On the side of the diagram, we find glass division. When the glass arrives to the shop, it needs to pass in a check and classifying process before going to assembly. Because it's necessary to take care of any defects or conditions that could affect quality and warranty of the product. This is the reason to create the lateral glass division. To classify before assembly, they use glass release, palletification, and glass by pallet. Also follow the standard operating procedure, or SOP, which is a logical sequence to make every step flows safely and accurately. With the glass already loaded, people proceed to open the crate, following the glass crate opening and securing SOP, which says, wear proper PPE or personal protection equipment. When crate is safely set on the glass rack, secure load with rope. Rope to be placed no lower than 12 inches of the top edge of glass and left on as good slate has been removed. Bend or remove any nails. This part is to avoid accident and glass damage. Glass inside the crate should not be loose. Choose the appropriate forklift that can handle the load, and check rope and glass before manipulating. The placement of the glass on the rack is done using glass rolling rack, SOP, and the sorting glass, SOP. Some issues we can find in glass are when handling glass, if you don't carefully follow safety protocols or SOP, things can happen like broken glass, incorrect placement of the glass, causing delay in the production line, or worse, serious personal injuries. Once the review, classification, and placement process is finished, the glass is taken sequentially to the stage set glass on assembly. Fabrication. If we follow the direct production line, we are going to find fabrication, where aluminum and other metal are machined. Also, in fabrication is attached a special part depending on the design. Each part in fabrication follow the sequence of the pallet schedule for a specific job, but also they use a cut list, which is specific, and all the fab tickets previously released from engineering department. The production in fabrication is per day. The machinery in fabrication is planned, which is slower than the other machine in shop, but it's used for more complicated cuts with minor and details. The other machine is Quadra. It's faster than other machine in shop, but its cuts are less complex. Diamond, it is used for holes and notches. And the Satellite XT, like Tony told us in his presentation, is basically the modern version of Diamond. In the fabrication process, the part needs to be marked with the mark number. Also, it will be cleaned using hair hose to blow any metal shaving off part or from the inside of part. It's important to make sure to wipe down any oil, dirt, or layout line on the part with alcohol wet rag and then with a dry rag without erasing the mark number when the part is cleaned. When all parts are fabricated and its attachment installed, they will be placed on racks with a slot to separate each unit in the rack to a stage for the next division with its assembly. Some issues in fabrication. When the fabrication process starts, machine operator follow all SOPs in each fabrication stage and trust that all the release fab tickets have been reviewed and approved and the machine has been programmed. That is the reason why the programmer performed a last back check looking for any issue. However, while the production is running, some problem can occur, like the machine operator doesn't follow the SOP or he is not focused and make wrong process affecting the part. Many of these problems are discovered in assembly, delaying the production line. This includes the wrong mark number or not have marked it, wrong attachment installation, incorrect placement of the parts in the pallet or in the rack, delaying the production line. Some issues related to fab ticket are discovered while fabrication is in process, having to communicate with with PCs, PMs, or programmer to consult or fix the issues. The best is to find the issues early and avoid to cut the part or discover the problem in assembly. Sometimes the machinery has malfunction and the maintenance department try to fix it as soon as possible. Either way, problem must be taken advantage of, becoming part of the feedback loop from which we all learn to create new improvement strategies. Continue with our diagram in the direct line of production. Like a big Lego system, when all parts are ready and placed on its respective racks, with 1 to 6 units, depending the pallet schedule, the assembling of each unit starts. Although most of them follow regular process based in chop drying and unit fab. Some have special conditions that require care and attention on its assembly. The assembly line is designed to be efficient, following a system of stages with a specific task, achieving a specialization and quality in each of them. The unit production varies based on the pallet schedule, and the quantity called per day can be set depending on how complicated the unit assembly is. There is a takt time to push the unit on rolling scaffold to the next stage. It's a big circle dancing to the takt time rhythm. The stage in assembly line also varies with the necessity or how complex the project is. But normally we find in it pre-assembly, assembly, gasket trim, joinery, set glass, caulking, trim, and QC. The first stage in assembly is pre-assembly. This is the transition from fabrication. Normally, it's a stage just for one person, but there are some projects with heavy part, especially vertical, so it's necessary to add more than one person. In this part, it's important to have available a copy of the pallet schedule, a copy of the unit fab, and some other things like black markers, pencil, highlighter in different colors. People in charge on this stage need to understand the mark number of each part match with the mark number in the unit fab to be able to locate every part from the rack to the scaffold. The first thing to do is bring up the rack from the pick line between fabrication and assembly to the workstation. Then take the unit fab copies which come with the rack to compare with the pallet schedule to make all the necessary marks or not. Pre-assembly is standard operating procedure. To keep constant improvement and quality control in each stage and visibly located, there is a copy of the respective SOP for the stage. In this case, place part on the scaffold per the unit assembly drawing. One scaffold needs to be always ready. Highlight the unit assembly drawing to ensure all parts are present. If not, look for it or ask in fabrication. Mark the head member with pallet number and unit ID. On the pallet schedule copy will be highlighted the unit loaded on the scaffold for production control. And the unit fab or unit drawing will be checked and placed in the scaffold because each stage will be used like the main assembly guide. When the takt time finishes, the scaffold is pushed to the next stage. Assembly. Some units are easy to assemble, but there are many complicated. A deep analysis of the location of every part will be done in assembly. It's not just screwing and that's it. People in this stage need to read and understand very well the unit fab and shop drawings. In all moments, they are supported by the line coach, the QC supervisor, and the shop foreman when something looks weird. And it's precisely here where most of the issues are found. Maybe it's because until the pieces are joined, we don't realize that something doesn't fit. However, they try to fix it while production line is running. In many occasions, they succeed, but in others, they need new part or consult to engineer department about the issues, requiring to leave the unit on hold, which implies leaving the pallet incomplete for packaging, and that means delay. Due to this stage joining all the pieces, it's right here when critical part bring all the special attachment, including aluminum panels. The assembly standard operating procedure is double check to make sure that all parts for the unit have been highlighted to avoid missing items. When most of the parts are already joined. Using the proper fastener, assemble the frame before this. Using the proper fastener, assemble the frame. Before this is very important. Check the correct location for all parts. Sometimes parts look similar, but the difference is slight. For example, the SRT or the location of the capture horizontal. Clean all the surfaces that will have silicone applied. Use the rack method. The process implied a wet alcohol rag to clean especially oils of fabrication, and then a dry rag. Using primer, primer all areas that will have silicone applied. It's necessary to apply only on the surfaces where the silicone will be applied, because primer can damage the aluminum finish. Using the black light, when using the black light, check using the black light. Using the black light, check for proper coverage with the primer. Step 4 and 5 are important, because if the primer is not adequate applied, will affect the silicone adhesion to the aluminum. Using a red Sharpie, mark all assembly screws to ensure proper installation. It's a kind of double check to avoid issues in glass installation. I'm going to add the adequate check of the QC checklist on the unit fat reverse. When all units parts are assembled, it's gasket trim time. The idea is removing the part of the gasket that is left over, but in a way that keeps water access blocked. It's a simple process, but if people in charge are not careful, it can affect the quality of the unit. There is a standard operating procedure to ensure that it runs properly. Using vinyl cutters, make the proper notches of the gasket. At the top of each opening, the vinyl will run long past the glass opening. At the bottom of each opening, the vinyl will be cut to opening size. To ensure the QC, check to make sure the screw head are marked with the red marker. This is a double check of assembly. To ensure QC, use the UV light. Make sure primer is present where necessary. Leave the gasket installed for the next station to ensure the proper trim and length. Immediately after gasket trim is the final seal, the gasket and joinery. When silicone is dry, it will avoid the moving at the corners, but the most important function is to block water that can go inside the window through joints. The joinery SOP. Before starting, make sure all gasket is properly trimmed. Apply silicone to the proper areas. Reconnect the gasket. Make sure there is silicone where the two gaskets meet. Using Tysac to the necessary areas. Once complete, initial the vertical by the joint. This is a kind of QC. Something else about this stage is that people need to do a clean job, because silicone can stain glass, and that is really bad when it happens if no one realizes about it. And it's worse if it will be installed back panel for that glass. Set glass. The scaffold with the unit assembled should be appropriate trimmed and sealed, and each gasket and joinery when arrived to set glass. Something important is that people in charge should have the rack with the glass of the pallet in a stage in the assembly process. The standard operating procedure to set glass is check assembly screws are marked, gasket is trimmed properly, and joinery sealant is properly applied, because after glass is placed will be hard fixed. Per the assembly drawings, locate the proper glass. Prior to picking the glass, make sure the picking surface is clean of dust and debris. Pick glass using the suction cup. Then remove bottoms of the back of the glass. And spray and wipe glass. Turn glass flat and scrap excess caulking off edge. Grab two racks. Apply alcohol to the first rack to clean edge, and use the second rack immediately after first rack to dry off the alcohol. Set glass tight in the proper opening of the setting block, and make sure it's the right location from left to right. QC the glass from correct orientation and mark glass properly with a glass pen. Remove a sticker from the glass. Some important things in this stage are that the glass must be in correct position, because once the caulking is applied, it will be difficult to fix it. Also, the aluminum surfaces where the caulking will be applied must be primed. The SOP to apply the structural caulking is tape to be applied on the male vertical. Position the tip in the proper angle and shoot the necessary areas. Make sure to go in the proper speed to ensure the correct amount of sealant is applied. Tool the necessary areas. Be careful when tooling to avoid making a mess. If tape is present, pull the tape and clean off any excess sealant of the frame. Quality control the shooting to ensure there is not voids. In this stage, every day a caulking sample should be taken for testing. Trim or attachment and QC final cleaning. In this stage will be installed all accessories that could not be installed in the second stage, because it was necessary the glass be installed and the caulking applied. The SOP to follow is per the assembly drawing, place trim part in the proper location. If required on a unit, apply trim to receive exterior cover. Align face stop in the proper location and apply the proper gasket. If required on a unit, apply exterior cover. Align the exterior cover with seal face stop, or as required per assembly drawings. QC the frame and clean as necessary. The process for this stage may vary depending on the part to be installed. Another thing that could happen is that the finished unit could be selected for testing as part of the quality control. With this stage, the assembly line is finished. However, as I say, the number of stations could vary depending on the project. Random test. Every day, from the assembly line, a finished unit is selected to do the water test. This checks if the assembly procedures are correct. Every day from the assembly line, a finished unit is selected to do the water test. This checks if the assembly procedures are correct. If not, it will be important to find the problem. Even the production line can be stopped until the problem found in the water test is fixed. Other important tests is other important tests in the shop are the pull test and the butterfly test. Both are to get the caulking quality. The idea of constantly testing the unit is to guarantee high quality in the finished product. And the last part of the presentation is packaging. It's the last part of the shop production. After this, only shipping the pallet to the field remains. For packaging, it's necessary to check a schedule for size of units, because with this information, we are going to select the size pallet. In all process, the unit must be protected using foam, especially all wood that could have any contact with the glass. The unit will be loaded following the pallet schedule. For facility in the field, the order of installation. The pallet must have a solid wood structure to protect the unit, and will be covered with a tarp, and legibly write information for job on it before the RoboPack make the last plastic cover. Finally, the pallet completely covered will be secured with green banding and stored waiting to be sent to the field. And all this is an overview about the shop production. If you have any question.
So, Edwin, can you back up a couple of slides to the stage 7 where it's the trim?
Let me to look for it. Okay. So when you tell me stream, okay, trim.
Yeah, it was assembly stage 7, the final trim.
Okay, it's this one, I think. Not this one.
So one of the things that I'd like to point out is that the shop has SOPs that they follow. And Edwin, you pointed out that there is one of these SOPs attached at each station so that they have that nice visual control when they go to do each portion of the operation. Well, one of the things that they will see, they'll have a copy of the unit assembly drawing that also tracks with the unit as it goes through its stages. When we have units that have extended covers or horizontal face stops, for example, and it's not obvious where those connections meet with the verticals, then that's why we put the notes on there that say, for example, your sill member might be the FS1, and we put that note on there that says FS1 equals daylight plus 1 and 11/32 on the left. That way, when the shop gets to that stage, if they don't have a good visual on the unit itself, in this case, if you have an Inviso on both sides, it's hard to tell where that horizontal face stop would align without some kind of a visual control. So one of the ways that the shop uses the engineering visual control is having that note on the unit assembly drawing. Some of the cases where we don't use that would be if you have a jam mullion and the horizontal part butts up tight directly to that. So there are certain conditions that the shop follows based on the logic of the system where they wouldn't need an additional note. So that's why when we're doing our engineering processes, some units will have those notes on them, while others don't, even though they might be on that same curtain wall. So I just wanted to point out that that's a good tie-in with what we're producing in engineering and how that translates and gets actually assembled and produced on the shop floor.
Okay. Thank you, Bill. I don't know if there is any question.
Any additional items, questions?
Add on to what Bill just mentioned about the notes, not just pertaining to this, but anything that you guys see that's very common that can be somewhat standardized, or you have a question like, oh, can this note be standardized? Can we talk to the shop about it? Just, you know, bring it up, you know, and then so they can talk to the shop and see if we can standardize it. Like I know Pedro and I talked to the shop about the note that we do with the bolted units. It used to be a long note telling them what kind of bolt to use and whatnot, but since they have a standard practice of what to use, we just agreed on we're just going to call it just bolt together, and then they'll look at the condition and they'll bolt it depending on the condition. So if it's a vision glass you can't see anything, they're going to use a coupler and hide the one channel and so on and so forth. So
I had a question.
Okay.
Yes.
So Edwin, when you were in the shop, did you get to work in all of those different departments?
Sorry, Steve, I can't hear you very well.
Oh, when you were in the shop, did you get to work in all those different departments?
Yes. In fact, my coach line told me that when I was working there, he told me, hey, Edwin, you need to learn all about this. Normally, a person keep at the same stage, but they try to show all that process. And yes, I work in all the stage in assembly. Sometimes fabrication one help, and the coach line tell me, okay, you can go to help them, but yes, basically I work in all the department.
No.
Mm-hmm.
And do you think, you know, when we're with what you're seeing in the office, like do you feel like the product that we're producing, like when you were out on the shop floor, was there anything we could be doing different that would help the guys on the floor based on what you're seeing now?
Sorry, I'm having trouble with that.
It's okay. Just, you know, in terms of, you know, now that you're in the office and you're seeing what we're doing, are there any ideas you have of things we could do to help the guys on the floor?
I don't understand you, Steve. Sorry, it's because I don't listen you very well. I don't know. Right.
So let me paraphrase Steve's question
Yes.
for you, since I speak loudly into a microphone and he's on a laptop.
Sorry,
So
Steve.
basically what Steve's asking is that now that you've had experience in the office and you can relate that to what's happened to the shop floor, do you have any ideas about improvements that we might make that could benefit the guys in the shop?
Oh, well, no, in fact, I realized that something that in general department, something that people do is to try to go on a step forward to avoid the problem in the shop. And normally when a job when I work in the shop, normally all was think, all was fixed, and I don't remember a big trouble for. And that means that in this moment, no, I think general department is doing a good job about all the material that goes to the shop, I think.
Okay, additional questions for Edwin? I had one additional point that kind of caught my attention, is that as you were going through, you mentioned that the shop actually has some QC processes, and they introduce the feedback loop so that if there's a problem, they can discover it and then they can take action to correct that problem. And especially what caught my attention was that if they're doing the water test and they find that there's a problem that's causing a leak, they actually have the ability to stop the shop production line to be able to boil down what is it that's causing this leak and get it fixed. So if that's the case, they may have the ability to update their SOP as necessary. Let's say they have a similar part on a system, but it's got a unique shape where it's difficult to do their caulking detail. Well, maybe they have to introduce some special step that points out when you have this part, you have to caulk it in a certain way so that it doesn't leak. So having that type of a feedback loop as part of the process, it just, for me, it reflects on the way that we need to approach that in engineering as well. So that if we see that there's a problem, recognizing that, and then getting to the root of that problem so that we don't perpetuate that same issue over and over again.
Yeah. Yeah, in fact, I remember a case, I don't remember what project was, but we had, when I was working in the shop, when we installed that panel, it was a panel, I remember, we have trouble with the caulking. After that, we put a lot of caulking inside, and I don't remember what project was, but I remember that engineering department give advice for to fix it, and it worked, I remember. But yes, in the shop there are a lot of people with capacity to fix a lot of problem, in fact. And I remember that we found some problem, and the line coach, the supervisor, Jose Gonzalez, very smart people, everybody has a capacity to resolve a lot of problem, yeah.
All right, any additional questions for Edwin? No? Okay, well.
I just want to add something. I want to show my gratitude for all people in shop, and to Jose Gonzalez, to Chris Green. I remember other people like John, Kevin. Everybody helped me, and for this research. I want to say I'm sorry, because really it's very extensive research. It's just an overview. There's a lot of information, and it was a little hard to me, especially because you understand me. You gave me the opportunity to work with you. I'm in process to learn, really. I want to say thank you to everyone in general department, because everybody's helped me, I know that I need to learn a lot, Bill helped me a lot. And I know that I can do all the things better. Yep, I don't have fear for to participate, and I hope this won't be the last time, because for me it's a challenge. You know, it's something that I can do. It's something that that I know can help me to improve. Sorry for some problems, you know, and it's a little hard to me, but you understand me, and that's great. You're really great partners. Thank you.
Great job, Edwin.
Nice job, Edwin. Very good. Thank you very much.
No, thank you to you.
Great job.
Thanks, Edwin.
Gracias.
Gracias a ustedes. Thank you to you.